right, so let's talk about the practice activity for SWA1 for Advanced Network Management. So there you go. We got assessment instructions here. Basic routing and switch installation configuration, OSPF, version 2 and version 3. Don't judge me. I know I haven't taught you version 3, but I'm explaining how to configure version 3. So I'm actually giving you the commands, okay? OSPF version 2, version 3, they work similar, you know? The concepts are all the same, LSDB, areas, all the concepts are basically the same. The only difference is OSPF version 3 runs on top of IPv6, and it uses linked local addresses for sending the updates between the routers, but that's all. And I'm giving you the commands. So, you know, had to create a bit of a challenge, you know? So there you go, the scenario. So you're gonna do basic routing, switch configuration and installation, OSPF version 2 and version 3, standard and extended ACLs, net for IPv4, Windows client machine network adapter configuration, and basic network troubleshooting commands. Shouldn't be a problem at all. And then you got a few comments about the attempts. You have to complete this assessment in under 2 hours. That's way more than enough, okay? Now, this assessment is of course inevitable. And then you've got the scenario. I'm gonna read the scenario because people never read the scenarios that I spend so much time building. Stark Industries has recently hired you as a gateway network engineer. They hired a network designer which has already created the network design using Cisco Packet Tracer. Now it is up to you to configure, test, and troubleshoot the network before you perform the tasks in the real equipment. All right. And then you've got your primary mission is to ensure that after you configure and troubleshoot the network, connectivity between all the client machines and the server is established. Please follow the steps below to install, configure, test, and troubleshoot the network. So you're basically going to follow a systematic approach of doing things. You're going to configure devices one by one. You're going to set up the IP addresses. You're going to test connectivity, make sure everything works, and your job is done. Okay? There you go, your $3,000 a day, okay, for being a contractor. So here we have an IP addressing table. I'm even happy helping you guys out. Check it out. I made the same color here and in the network diagram. How cool is that, Fred? Yeah? Telling you, I spend so much time doing this and you don't even read the scenario, you know? Some people just open up, okay, scroll down to the addressing table. Mate, you know? And then you complain the teacher is not creative enough. So there you go, you got the same colors here. Have a local area network here, which is Stark Tower. And then you have another local area network here, which is the Malibu Mansion. Okay? And another one here, which is the Avengers headquarters. It's your task to connect all these things up. Okay? So that's the purpose of the assessment. By the way, because people wanted to save some money, okay? Stark has a lot of money, but he wants to save some money sometimes, okay? And then he just basically have one internet plan in one of the sites because, you know, he's a cheap person. And it's connected to this Stark Tower. So there's no connection in any other sites, okay? So that basically means all the internet connection has to go through here, okay? By the way, I have created a server here on the internet for you. The www.mcu.com server, okay? Which displays a web page, custom web page that I spent time building. And here it says it's an NBN connection that you have to the internet. So of course Stark pays TPG, you know, because TPG is cheap. Yeah. He's a cheap guy, I'm telling you. And then this internet connection to the router, this router actually obtains the public IP address from the internet, from the ISP, using DHCP. So if you configure this interface of the router as IP address DHCP, this router will obtain a public address from the ISP automatically because I have set this up for you already. Okay?
Thank you.
And by the way, there's also a DNS server here on the internet as well that I have set it up for you as well. Okay? That resolves the www.mcu.com, and it also resolves the intranet server here. Okay? There is an intranet web server as well, Fred. Okay? To keep all the files confidential. Okay? So you can only access the private web server if you are in any one of these sites. That's why it's called the Internet Web Server. You know what the www address is? HTTPS, because of course it's protected, okay? It's secure. And it's HTTPS semicolon / internet.mcu.com. And you'll be able to access the private server that I have already configured for you as well, okay?
How does the external DNS server resolve the internal website?
That's just because I didn't want to configure the router to be the DNS. I was lazy. But usually what is done is you set the DNS. When you have a private server on your network, you set up the DNS resolution on the gateway. And then you set up the DNS to be the gateway. And the gateway will resolve all the DNS records that it knows. So that basically means the internal ones. And the ones it doesn't know,
Sent outside.
internet,
So
ISP.
we have to configure the DNS on the
No,
device as well?
no, just the way it is, it's going to work.
Yeah.
So you just need to be aware that the DNS address you have to use is this one here, 209.101.1.2.1.
Yeah.
If you use this one everywhere on all the clients,
Yeah.
and you try to access the web page, both the internet one and the private one, it will work. Okay? And job's done. Alright, cool. Mate, the resolution here is horrible. Alright? So check it out. The tasks. So for step number 1, you inspect the network. We just did that. Okay? As a matter of fact, I blocked certain features here. For example, you're not allowed to delete anything. Okay? I really find annoying when the teachers block for you to move stuff around, because sometimes you like to move stuff around, right? So I didn't block for you to move stuff around because I think it's nice, you know. Some people like to move stuff around. You like to move stuff around, Shai?
Because sometimes you need to see the interface's name.
Exactly. So it's quite useful. But you're not going to be able to delete stuff. You're not going to be able to add new connections. It's just the way it is. Okay? Now, you will have to configure all devices. That includes all the client machines, PC0, PC1, and the server. You have to configure all the routers. Router 1, 2, and 3. All right? So you basically have to follow along all the instructions. You have to set all the IP addresses, both IPv4 and IPv6. You also have to configure the host devices. Every host machine will be configured with the first available address in the local area network that it belongs to. So for example, PC0 needs to have IP address 192.168.1.1 because it's the first available. And the last available will be the standard CIT procedure. Okay? Some people that work in the industry criticizes me a lot for doing this. But I'm the teacher, all right? So that's my choice. I choose to be that way. Okay? I'm the designer.
Why did they criticize putting the...
I don't know, because some people say, oh, the top one should always be the gateway. That's it.
Oh, I have that.
All right, so then you have PC1 with IP address .2. And then you have PC3, IP address .4. And to me, it just doesn't make sense. But it's your choice in the end. Right?
But in the industry, they do 254, like at Services Australia. They just
Some places, yeah, some places. The good places to work for. See that? The good places to work for, they do that. And all devices, they should generate their own IPv6 address using EUI64. I'm just basically telling you to go on the machine and in the IPv6 address configuration, change it to automatic. All right? After you configure the router interface, router solicitation, router advertisement, remember routing switching? You get the prefix, you generate your own IPv6 address. Job's done for IPv6. Cool? And then you have the OSPF configuration. You have to configure the devices with the router ID. You have to advertise the networks appropriately. And you have to set up the passive interfaces, of course, which are the interfaces connected to the local area networks. And you follow along all the instructions. For OSPF version 3, I'm actually giving you the commands. Okay? Just so that you don't criticize me for not teaching you this, I'm giving you the commands. I even highlighted the commands. Check it out, mate. I spent time doing that, mate. You know? And then configure the ACLs. And I'm even giving you a very important hint. And I'm going to leave the same hint in the real assessment. Okay, so leave this step for last because it breaks stuff if you don't do it properly. And then you're going to spend time trying to troubleshoot something else, but when the problem is actually the ACL that you haven't configured properly. And then you have to configure NAT for IPv4, create a standard ACL that will identify the interstream traffic. So that basically means the traffic for all the local area networks have to be translated because otherwise they won't be able to access the internet. And configure appropriate NAT interfaces inside and outside. You're going to configure NAT so that only one public address available is overloaded. So you're basically configuring port address translation. Remember the overload? And that's it. And then before you attempt this task, please make sure you assign a static address for each machine, PC0, PC1, and server. And you assign a static address for each machine as per the IPv4 addressing table. Using the web browser, access the following websites. www.mcu.com, which is the public web page, okay, hosted on the internet. And the HTTPS internet.mcu.com, which is the internal private website, which is only accessible from any of the sites here. Okay?
Why do we have to assign static IP addresses for the PCs?
Just because I wanted to. Yeah. Yeah, it could be DHCP, you know. But I was thinking about doing DHCP, but then I thought if I give them the DHCP, I will tell them to configure it. But DHCP configuration is part of routing and switching.
Okay, so
And not everybody has done routing and switching.
yeah.
So I'm not going to ask them to do that.
Yeah.
So I can probably already configure the routers with DHCP, but that will defeat the purpose because then I would have to configure the interfaces already to do that. And I just said, no, let's just go with static. And that's it. And you just have one machine each side, so
Yeah, easy.
it's all good.
I'm not sure if this question's allowed or not, but when you assign an IP address to a router, do you just make the router ID be something?
The interface.
Make the router ID be the IP address something, or do you mean something else?
When I say assigning an IP address
Part of the thing, you have to assign IP addresses to each router.
to each router interface.
Just the interface.
Yes. But that's why when you check the addressing table, it actually specifies the address per interface.
Yeah.
Because there's no way you can assign just one IP address for a whole router.
Yeah.
It has to be per interface
Yeah,
basis.
that's why I was asking these questions. I was like, oh, is that the router ID instead or something?
Yeah, that's all good.
Thank you.
Now check it out. I'll give you a hint here because this is going to be useful for you guys next week as well. So once you figure out my advice to you, configure one device next week. Okay. Double check your configuration. Okay. Write the configuration on a TXT file and then copy paste to create the configuration for the other devices because that's going to save you some time, especially if you're a slow typer. Okay. So if you type things really slowly, do that. Okay. Grab a notepad, type the commands, copy paste them in the router config, and then you use the same ones as template for the other routers. But make sure you make the necessary changes. Okay. So in this example here, let's just score 100% very quickly because we already have the answer file. I'll just show you guys that it's possible to score 100% following the instructions. So the first thing I'm going to do is I'll grab the configuration for router 1. When you're copying pasting configuration, you have to basically remember that the router needs to be in the correct mode. So my configuration starts with the enable. Where do I need to copy paste this? In the user mode or any mode which is higher than that. Okay? So I'll just grab from here. And do you guys know what the exclamation before something means?
Comment.
A comment. Okay?
If you do two, does that make it be an extended?
It's still a comment.
Right.
Just a normal comment.
That was the thing I was thinking about.
So check it out. I'll grab the first router config and check it out. It's just interface configuration. Yeah, IPv4, IPv6. The NAT configuration here as well, because this is the router connected to the ISP. So this is the inside interface. Of course, we have a no shut to enable the interface. The other interface is super easy because it's just a point-to-point connection to another router. So just simple IP address, IPNet outside, no shutdown, the gigabit 001, IPv4, IPv6 addresses, the link local addresses as well as per the addressing table. This is also a net inside interface, no shutdown. Here's where you're going to create your default route, which is just basically telling the router, if I don't know what to do with this, I'm gonna send it out to the internet. Yeah? The internet connection is an NBN connection that is being done through gigabit interface 000. So you're basically telling the router, if you don't know what to do with this, send it to the internet. So this is the static route or the famous quad 0 route, because it's quad 0, quad 0. Yeah. And then you have the OSPF configuration, OSPF version 2. You're initializing the OSPF process, you're setting up the router ID, you're advertising both networks that you have on this router. You are doing this. What is this doing? The other routers, they don't know that there's a way out there to the internet. So if they receive a packet, they don't know what to do with it. They will drop it. So the default information originate is telling router 1 to tell all the other routers, hey mate, if you don't know what to do with it, I will, because I have a connection to the internet. So that's what this command is doing. It's advertising this default route to the other routers. Job's done. Okay. So you are not going to execute this command on the other routers. Does that make sense? It's just on this router. Because this router is the router that will inject this default route into the OSPF database. Once it's in the database, everyone will have it, right? At least everyone in the same area. And in this case here, everyone is in the same area. Backbone area, area 0. Is that clear? And then what else? What is this doing?
Not advertising to the
OSPF packets, not sending any hello packets to the local area network because you're not expecting to find a router there. What is this doing?
Creating the access list.
Creating the access list. This access list is a standard or extended? It's a standard. This access list will be used for NAT. So this is basically going to be used to say these 3 local area networks are the one that will be translated to the public address, and that's it. Okay? This is the NAT command that you need. IPNet inside. The inside addresses will be the ones that match the access list number 1, which is just basically the 3 local area networks. And they will do what? It will translate to the public address that interface gigabit 000 has. And what is this doing here?
It means you can use
It's overloading. It's using PAT, port address translation, because you just have one public address. Job is done. And then you have to enable IPv6 routing so you can configure OSPF version 3. I gave you the commands, so don't complain. All right. And then you've got, yeah, I gave you the commands. So no complaints. And then you got the same thing for router 2. So the only difference is on router 2, there's no default information originate because router 2 is not connected to the internet. There is no NAT on router 2 because router 2 only knows about the private networks. And it will receive the default route from router 1. Same thing goes for router 3. All right. Job's done. So let's check it out. So I'll just copy the entire config. Now, it's really important when you copy pasting stuff, you are aware of the surroundings. And why do I tell you this? Because when you copy paste, you're gonna go into global configuration mode. But if you type it in that you wanna go to the interface, for example here, you are now going to be in interface configuration mode. So if you're going to type commands later on that are required to be typed in into global config, you will need the exit. So you can go back one mode. So only copy paste stuff if you understand the modes, and that you have to go back sometimes and you have to go forward sometimes. All right? Clear? All right.
Robert, do you think we should, in the exam itself, do you think we should start with the border router first and then do the other ones, or
Doesn't matter.
would be the most
Up to you.
complicated?
I would start with the internet router first, the one connected to the internet, because it's actually going to be the one with most amount of commands, and then you can just copy paste and remove certain things. That's it.
Sometimes the packet tracer skips over a couple of commands that you're going to look at. Like I tried to, started from enable, cut and paste the whole lot in, and it actually skipped a batch of commands and went straight to the interface a couple of times. The real routers never do it. Yeah, you try
Could be the version, because I actually did this and it worked.
No, it doesn't happen.
So check it out.
It just happens sometimes.
Router 1, so yeah. So to copy paste, you just need the file, yeah? Copy, and then go to the packet tracer, CLI of the router you wish to copy paste. And you just basically click here, paste. And you can just confirm that everything has gone through. Check it out. Sometimes what actually happens, Rob, is that when you type a command, you are interrupted by a log message. But that doesn't mean that the commands are not being transferred yet, because they actually are. So here, for example, once I typed in the no shot, it generated a log message somewhere, and it interrupted the copy pasting, but it still continued afterwards. So the whole config is still there.
Had to try one router, with just one router playing up. And in the end, I had to actually type in enable and then just copy paste the config terminal all the way down. And that worked.
So it's
It was just skipping over. It's skipping over the first dozen lines.
So check it out. It looks like it skipped over here, but it actually didn't. It kept going. So you see here,
No, this was giving me error message.
but if you actually check, it's there. But if you're getting error message, it's most likely because you forgot an exit. Somewhere.
I'll show you.
Somewhere you're missing an exit. And then you're trying to type a command in the wrong mode. And it's most likely going to say invalid command.
Well, sometimes it can be that you type the interface number incorrectly.
As well.
I know, I'm absolutely sure that what I'm saying is right.
That's okay.
Because it's happened to me a few times. And then if I try it 2 or 3 times, you just control, I have just one text document, all the router 1 command. I just control A, control C, and then paste it in, and then it doesn't start until like the interface. It just leaves out like the first dozen commands. It's just
Yeah, that's weird.
Um,
I'll check it out later.
Yeah.
Yeah.
I'm just saying, it's just occasionally happens. If that happens, I've got to
what
relay
exam
the
do we
router.
have?
Alright, so it's all done. Router 1, 26%. That's it. Alright? Now, you see that router 1 has actually obtained an IP address from the ISP, which is good. That's exactly what you want. Alright? So that basically means your router 1 now has connection to the internet. Cool? And check it out. This is green now. This is green as well.
So
Yeah.
what command is enabling the DHCP, getting the IP?
Yeah,
to the
it's just the
ISP?
IP. You go to the interface. So interface gig 000 because this is an
Does that mean
NBN
IP
connection.
DHCP?
IP address DHCP.
That's it.
Job's done. Alright? Because you're not actually setting up an IP address manually.
Okay.
You're actually telling the router to request one. Of course, in the real life scenario, your router will still need to authenticate with the ISP using the credentials that you have with your NBN plan. Nowadays, you don't have to worry much anymore because most of the routers, they come pre-configured, preloaded with your username password. But you have a username password with your ISP. Every one of us have one. And when you actually want to buy and use your own custom router, so you go to Officeworks or whatever, you want to buy your own router because it's fancy, you know, and you want to spend more money. You buy one, but you have to configure it yourself. And then you have to call the ISP, mate, what's the username, what's the password? Has anyone ever done this before? Yeah? Rom has done it? Yeah. So that's how it works. Cool. So job is done. Now let's do router 3 or router 2? Let's do router 2, because it's right here. So just copy paste this until here. Router 2, CLI. Here, you're in user mode, right? Rob, there's something else as well. So for the first time, you have to click on the device, CLI. If you just try to dump it here, it may not work. You have to go and hit enter first to actually see the mode, the user mode.
Yeah.
Right.
I realise that.
So router 2, I'll just copy paste.
I've made that mistake before.
Job is done for router 2. Does anyone know why is this amber here on the switch and the router's green? You get bonus points if you know that, Fred.
Faces have to be turned on.
What is that? STP.
Listening and learning.
Spanning tree protocol, yes. There you go. Awesome. So job is done here. Now let's copy paste configuration for router 3. Whole thing?
We don't have to do anything with switches.
No, absolutely not. Just the default settings will do the job because everything's in the same VLAN. It's just one VLAN. Default VLAN. What's the default VLAN? One. What's the default native VLAN? One as well. There you go. Job's done. OSPF is working, doing the job. You know, you can speed things up because I had the option to block the fast forwarding time. But mate, it's so useful, isn't it?
Yeah.
So you guys have it, right? I hated the teachers that blocked that from me. Right? So you have the fast forward. There you go. Everything's green, just like a Christmas tree, mate. Yeah. You guys never laugh at my jokes. I'm gonna stop making jokes.
We got them though, they were good.
You guys have no sense of humor. So let's configure the IP address and check it out. So IP address for PC0. 192.168.1.1. And then I hit the tab. What's gonna happen with the subnet mask?
Autofill.
Is that the one we want?
Yes.
See, I make your life easier, mate. I could make your life harder, but I don't want to do it, you know? So default gateway. 192.168.1.254. DNS server is the one I gave you. 209.101.102.1. Job is done. Now you have already configured IPv6 on the router. Hit the automatic. Check it out. Yeah? This is what, Fred? Slack. Remember? Stateless auto address configuration. You talk to the router, you get the prefix, and you generate your own IPv6 address. Is this a randomly generated IPv6 address or EUI64? How do you know? You have FFE in the middle. Don't feel bad if you don't know that, and no one knows that because he's doing routing and switching at the same time as he's doing this. The guy is fierce. Okay? The guy is just crazy.
It's going to come up in the CCNA test?
Yes, for sure. Okay? If you don't get a question of any of the stuff I talked about here today in your CCNA, you come here, you talk to me later, I'll resign. Okay? Find another job somewhere else. Maybe drive the garbage delivery trucks and things like that. You know? So I could make the same amount of money. So I would just resign because that would be ridiculous, man. I'm not doing my job properly. So we do PC1 as well. Oh yeah, you did last semester. Oh yeah. PC1, 192.168.2.1. Default subnet mask, 192.168. Whoops.
That's the address from the DHCP server, right?
No, that's the static address we have to configure on the computers, based on the addressing table I gave to you. Like I said, this could be done using a DHCP server, but it's just not the purpose of these assessments.
Wait, no, but it's the address of the gateway to go out to the internet, yes?
Yes, this is the default gateway. But which default gateway is the one here for PC1? Is it router 1 or is it router 2? Why?
That's the subnets.
The gateway is in the same network as the client machines. And if you've done intro or routing switching with me, you know the analogy I have for the gateway and the door. Yeah? The gateway is the door to outside of the network. So the gateway is an address in the same network as you. In this case is 254.
I got this wrong in one of the Microsoft Internet bugging me out for a long time.
Same thing? Is this EY64 or random? Because you have the FFFE in the middle here. Yeah. There you go, your job is done here. Server. Desktop IP address configuration. 192.168.3.1, 192.168.3.254, 209.101.102.1. And check it out. 100%. But your job is not done yet, Fred. You have to scroll down because there are some questions here you have to answer. Using the web browser, access the following websites. So it doesn't matter which web browser you'd like to use. Just choose one, PC0 for example. Web browser. And then you go here, URL. www.mcu.com. If this was in real world scenario, which web browser would you use? Oh my goodness, mate. Firefox? Safari? Oh. All right. You can make your own life decisions, but there you go. Welcome to the MCU, okay? Have you watched our latest movies? And then you have the movies. Mate, I don't know HTML. You guys have no idea how hard it was for me to do this. I don't know. I'm not a HTML instructor, okay? So I had to actually do some research to just basically do this shit. So this is the one on the internet, all right? There is also another one, which is the Internet Web Server, which is this one here, server 0. And if you try to do HTTP intranet.mcu.com, do you know what's going to happen, Shai? It is not going to work.
It doesn't resolve it.
Do you know why? Do you remember what you did in the ACLs? What have you done in the ACLs?
We haven't done anything. You just copy paste
Here.
stuff.
The man's got a point. But there you go. IPv4 ACL that will allow HTTPS and ICMP for Stark, Tau, and Malibu, and deny any other traffic from any other destination to the server, to the internal web server. So that basically means, if you want to see the internal web page, change the protocol to HTTPS, and there you go. Oh, mate, I misspelled welcome. Seriously, I did this over the weekend, okay? Time that I could be spending with my loved wife, just to help you guys out. But there you go. That's how things work. So, if you do everything according to the instructions, it's going to work. Next week's instructions
Next week it's on the real equipment?
will be similar. Now, I'm still deciding on that.
Alright.
I'll get back to you guys probably on Tuesday to tell you if it's going to be in the real equipment or if it's going to be a beefed up packet tracer activity. Because the reason is we don't have enough equipment. Because we would need 3 computers, 3 routers, 3 switches for every single one of you guys.
Unless you make this change between line cons where you're doing different things, that's pretty hard to do about.
In the real equipment, yeah? Yeah, because you're going to have to plug it in the console cables. You have to configure one, configure.
One of the main translation things that we might have if we have to do it on real equipment is we have to enable line chunking or something. Is that the main thing?
What I might do as well is I assign you guys to one router each, and then you're gonna show it to me that you would be able to do it in one router. But then you would still have to do the packet trace anyways. So it's probably what I'm gonna do.
If you do the packet tracer and you keep your
Probably what I'm
text
gonna do,
documents,
yeah.
you can just put the text documents straight on there, can't you?
Yeah, but I still need to assess the capability that you have to actually configure physical real equipment.
What do you mean show you that we can do it on one router, so just configure one router?
Yeah, that's what I'm saying. So that's what probably I'm going to do.
What will be
I'll give you the packet trace activity, which is not going to be this one. It's going to be a modified one, different scenario, different IP addresses, but you know, tasks, same tasks. You know?
So is that it? Line, what is it, dot one Q something? That's the command that we need to remember that might be.
For which step?
Dot one Q something.
No, there's not .1Q here.
We're not going to use one router to switch all the LANs.
I know, but, but that's only applicable if we had to do.
Router on stick will do it.
Yeah, so no, there's no round on stick. There's nothing funny here. So
I was just trying to figure out what problems there would be ahead of time, so I guess I'm.
Any hints at all?
So if you have done routing and switching, you know that the practice activities, they're fairly similar, but not the same. So keep that in mind. It's not going to be exactly the same.
Look for annoying things you can do at least.
All right, guys, let's smash it up. I still have to deliver today.
So you're not going to give us a hint what else we should be studying?
That's all. Yeah, that's all.
Might be the surprise.
There is always a surprise, mate. There's always a surprise, you know?
Still going to give us a hint, maybe?
The hint is there's no hint. No, nothing new, mate. Nothing new. Nothing new. Maybe, just saying maybe. You may ended up with an extra backup link between these two routers. And then I may ask you, what is the chosen path? Is that gonna be the direct one? You know? I may play with things like that, but I'm not gonna modify the devices. So keep that in mind. I'm not gonna change the devices themselves. It will be these devices. But I may have a gigabit connection between R1 and R2. And I may ask you what's gonna happen if you have to send traffic from Stark Tower to Malibu Mansion. Is it gonna go through the gigabit link? Is it gonna go through the serial connection? Is it gonna go through the hop? Why? Something like that, you know? That's it. That's the hint. You know? That's the hint. It's just a hint, of course. Yeah? You can still do whatever you want in the end.
What's the bandwidth of serial connections? They are slowed in the
It's an incredible, amazing 1.5444 megabits per second for the T1 serial link.
But you can go further, can't you?
So basically means you're pretty much never gonna see that in the industry. Yeah. It just, it's basically not there.
Is there distance?
If there's a distance, a maximum distance,
No, I thought I was told that, yes, they use serial connections because they went further.
oh yeah, exactly. But nowadays there are way better solutions than the serial connection, yeah. Fiber or something like that. All right, guys, let's smash it out. I must warn you that there is a lot to cover, mate, for wide area networks. So what I'm actually going to do, I'm gonna actually try to smash it out as quickly as possible. Okay? What time is it? All right, let's do it. Main concepts. Wide area networks. You do a job search, Fred, because you like to get a better job, you know? And then you look for network engineer jobs. And 99% of the jobs you see two terms. LANs and WANs. Okay? So that basically means you need to know local area networks, which you already know pretty much. By the way, mate, if you have done your Cert 3, your Cert 4, and your diploma here, and you are not a master in local area networks, give up, okay? Be a sysadmin. But if you know how to manage local area networks, and you like doing that, and you understand the VLANs, and you understand the configurations, and you like those sort of things, definitely be a network engineer. You love it, all right? But today we're going to talk about the wide area networks. Okay, so I have divided this class into topics. We have the purpose of wide area networks. We have the operations of wide area networks. We have traditional WAN connectivity, modern WAN connectivity, and internet-based connectivity. So let's get into it now. The purpose of the wide area networks. What is the purpose of a wide area network? Please come and get into my time machine and let's go back to 2020. Okay, your first semester at CIT, and you were doing introduction to networks. Yeah, who was the teacher? Sam Caruso. Mate, Sam Caruso was my teacher for introduction to networks 33 years ago. Here at CIT. No, just kidding. Okay, wasn't that long ago, but he was my teacher, and he's so good, mate. I like that guy so much. But there you go. So he was actually telling you what a local area network was and what a wide area network was. And at the time, he just said, it's a limited area, you know, it's a small area, it's a local area network. If it's a wider area, you know, you have more devices connected to each other in a wide range distances, you have a wide area network. Right? But that was pretty much it, yeah, at the time. But here we're actually going to describe how the wide area network connections happen, okay, how they're made, and everything else like that. Okay? So basically here we have some local area networks. Of course, some of them have multiple VLANs and things like that. And you basically want to connect everything. Yeah? In the end, you basically want to make sure everything is connected to itself. Okay? Because that's your job description. Yeah. So basically the wide area networks, there will basically be these links. Usually the ISP will provide you links that have huge range, huge distances, and you basically pay them some money every month to lease their lines. Yeah. And there you go. All right. So private WANs provide the following. So we do have the private WANs and the public WANs. Some ISPs, they own certain wide area network links. That's why you see some trucks out there, Mr. Fred, laying cables all over the place in the city. Yeah. Usually there's an ISP spending a lot of money building the infrastructure for a wide area network. And of course, this is a capitalist world. They're going to charge you some money every month to use their infrastructure, yeah, to interconnect stuff. There are also the private wide area networks for the people that, and all the companies that can actually afford it. Microsoft, for example, doesn't want to pay ISPs, yeah, to use their public infrastructure. Microsoft is known to be laying cables on the bottom of the ocean, mate. From country to country. Google as well. They have their own wide area network infrastructure. Right? Interconnecting countries. So there you go. These are the benefits of having private wide area networks. Guaranteed service level because of course the company owns and they can do whatever they want with it. Consistent bandwidth and security as well because you can do whatever you want with the stuff that belongs to you, Andrew. Yeah? It's not the same if you're leasing. Right? For example, if you renting in the city, mate, you don't want to be punching stuff on the wall because, yeah, you know you're going to lose your deposit. Yeah? But if you buy your house, mate, you can do anything you want, yeah? You can put as many wall arts on the wall as you can. It doesn't matter. Who cares? But it's the same thing here, man. Now, the wide area networks, they're implemented using the following logical topology designs. They could be point-to-point topologies. They could be hub and spoke topologies, dual homed, fully meshed, and partially meshed. I don't want you to imagine all of this. I actually have some pictures here to show you how they look like. Okay? So there you go. This is a classic example of a point-to-point circuit. You basically want to connect two devices to each other. This is usually the classic /30 network. You have two available IP addresses that can be assigned to each one of the interfaces of the routers here, yeah? And your job is done. Okay? That's a classic point-to-point connection. The point-to-point connection also involves a layer 2 transport protocol such as PPP, point-to-point protocol, or anyone know the other one? PPP and HDLC. So these are the two point-to-point protocols. And of course, as everything in networking, one is Cisco, the other one is not. Yeah. Cisco is HDLC, which is the default protocol used by all the routers here. So for example, if you connect the serial cable from one router to another to create a point-to-point connection, you're actually using the HDLC protocol by default. Okay? PPP is another protocol. You can actually change it if you want. Okay? PPP is actually better than HDLC because PPP actually has authentication capabilities. And you, Fred, is most likely using PPP as your protocol to authenticate your home router to the ISP. And that's how they check that you are paying all your bills on time, and that's how they keep your internet connection up and running if you're paying them. Because if you stop paying them, Fred, at some point, they have to block your connection. Yeah, that's how things work. So the one that actually is one of the most common ones nowadays is something called PPP-oE, which is PPP over Ethernet. So that's what your NBN modem is doing. It's not a serial connection to your NBN, right? So if you have a router and an NBN connection, you know you have the modem, you have an Ethernet cable connecting to your router. That protocol is PPP, but it's PPP-oE over Ethernet because it's an Ethernet cable. But the authentication and everything else that is used by PPP is there. And that's how your router authenticates with the ISP. It's what we were discussing in the beginning. You have a username, password, you authenticate with the ISP, and then, of course, the ISP will check, yeah, will do the authorization, it will verify that you're paying all your bills on time, and it will then allow you to continue to browse Google. I was doing a survey, I was asking this question in all my classes. Who should win the title of the professional that Googles the most? Option number 1, a cybersecurity specialist. Option number 2, an IT professional. Option number 3, a software programmer. Or option number 4, your GP. I reckon it's the GP, yeah. For sure. So there you go. You have hub and spoke topology as well. So hub and spoke topology.
Just a quick question.
Yeah.
So when you said that it's authenticates, it means that all the traffic is being encrypted?
Not necessarily. Not necessarily.
Just for the connection? Just for creating the connection?
Just for authorizing the router to connect to the internet, to the infrastructure. So think it this way. If you just, all the NBN boxes, they come with the house that you buy. So the box is there for anyone to come in and plug it in a router. What's stopping people from accessing the internet without having a valid NBN plan? The authentication method, right? So you have to call an NBN provider, mate, I want to get an NBN plan. And then if you have your own router, they will give you a username password. And then you configure the router with the username password. The router will communicate with the ISP and will say, hey, I got this guy here. I belong to him. It's shy@iinet.com, whatever. And then the password is this. And they'll say, okay, this matches our database. Shy is paying the bills. Cool. You can access the infrastructure. That's how things work. Is that clear? All right. Awesome. Cool. There you go. We have a similar one which is called a hub and spoke topology. In a hub and spoke topology, we basically have only one node and one connection per router. So usually in a hub and spoke topology, we have devices that only have one connection. Okay, and that basically means one router will be like the central router, and all the other routers, if they want to talk to each other, they actually have to send the traffic to the hub, and then the hub will send to the other spokes. So this is a classic one that is implemented in some called DMVPN implementations. Okay, but that's a bit too advanced. For you, you just need to know a hub and spoke topology and how it looks like. Okay, you just basically have a central router, and all the routers are actually connected to this router. There is no communication between the spokes directly. So all the communication has to go through the hub. That's why it's called the hub. And that's why it's also known to be a single point of failure. Because if the hub fails, that's it. Okay? There's no communication between the spokes. Cool? All right. What's a dual home topology? A dual home topology is when you have multiple edge routers. All right? So if you have multiple edge routers, usually for redundancy, layer 3 redundancy, right? If one of these routers fail, you still have another one. You still have connection with the spokes. So you're basically eliminating this single point of failure. It's now gone because now you have multiple hubs. Okay? Fully meshed topology. What is a fully meshed topology?
Everyone connects to everyone, so it's the same.
All the routers are connected to every single one of the other routers. Okay? Of course, there are many, many benefits of having something like this, right?
Yeah.
You have redundancy at the highest level, mate. If this link goes down, you still have communication with all the other routers. If this link goes down, you still have communication with all the other routers. But the thing is, mate, the ching-ching, yeah? Because you're actually paying for the router interfaces. You can buy an ISR 4331, which comes with an incredible 2 gigabit interfaces, okay? And it costs $4,000. $4,000. Or, if you have a lot of money to spend, you can buy, what? A 4351 with an incredible 3 gigabit interfaces for a little bit over $12,000. Okay, so it is way more expensive to have something like this.
You also have 10 gigabits interfaces, not.
Yeah, the SFP and yeah, you have the 10 gigs as well, the newest ones. Yeah. There you go, and you have these partially meshed topology as well. You know, it will solve some problems in terms of redundancy, not all of them, but yeah, you still have some sort of alternative path. Okay, so for example, if this guy fails, all the other guys can still talk to each other. If these guys fail, all the other guys can still. If these guys fails, these guys can still talk to each other, but not to these guys. So you have some sort of redundancy. Okay, a little bit, not too much.
Robert, those routers in the WAN, they are configured with BGP?
That depends. Usually the enterprise routers, they are configured with BGP, but the thing is, the BGP table nowadays is a little bit over 800,000 entries. And do you know what the BGP table entries mean? The internet. A little bit over 800,000 networks in the BGP addressing table nowadays. So that basically means, mate, if you try to configure your home router, which is $100 with BGP, it's gonna
Crash.
shit itself up. Yeah. So it's just not gonna work. That's why we have routers which are so expensive. $4,000, $5,000 enterprise level routers, because they can actually learn all the routes on the internet. 800,000.
Is that like DNS?
Huh?
Is that like
just about advertising all the networks out there on the internet. Yeah. So all the paths to go through. All of them. All the public ones. Alright. Talked about that already. Of course, if you are actually talking about a public wide area network and you're paying an ISP, you will have these. Yeah. The service level of agreement. You pay them, they agree to provide you some sort of level of service. Yeah? And that's usually highlighted as the availability. 99.99, 99.9999, whatever. Basically means if you have a 5 nines, you basically expect to have a few minutes in a year of downtime. Not more than that.
Is that only availability, or does that also roll into that as security?
Some ISPs will also highlight some security mechanisms being implemented, but not all of them. Not all of them. Alright, there you go. We have the single carrier connection, which is basically connecting yourself to a single ISP. Of course, this is the cheap way. Yeah? But sometimes the companies don't want the cheap way. They want the high availability. So they will basically pay 2 ISPs. And then they have 2 edge routers to each of the ISPs. Because if one ISP goes down, they still have another way to the internet.
So there are 2 public IP addresses.
Yes.
On 2 different interfaces.
Yes, from 2 different ISPs.
And 2 NAS.
Some ISPs, if you actually pay to have a static address, which is a public address from one ISP, you can inform the other one you already have a public one, and you can have the same IP. And BGP still knows how to get to you the optimal way.
So there is the protocol that you configure 2 routers to be redundant, and you have like a virtual IP address.
Yes, HSRP
HSLP, right?
as well.
So you can implement it on
HSRP, so you only have one public. Yeah.
and you can implement it on an edge router as well.
Yeah.
Yeah, right.
There's nothing stopping you from doing that, because then you just have one address here, which is the virtual address,
Yeah.
and one is a backup of the other one. And
Yeah, that's
so on. No, I talked about that already. So let's talk about small networks. So this is how a small network looks like. You guys are pretty familiar with this. Now, in terms of small networks, basically the access method being used is usually something like this. Now, the connection to the wide area networks is not Ethernet. It's usually something else. Fiber optics, serial, ADSL. Yeah, remember ADSL? So there you go. These are all the access methods here. And of course, because we're talking about a different layer 2 and layer 1 protocol, you need this device here. Does anyone know what this device is? It's a modem. Yeah. So there you go. A modem is basically responsible for converting the signals from one data type into another data type. And there you go. Your home router here inside.
Home router and switch, everything is consolidated.
Yes, your multi-purpose device, your all-in-one device. Yeah? And like all-in-one devices that are out there, it sucks, right? Compared to other solutions.
Yeah, but it's good solution for home environment.
Yeah, for home environment where people don't know the difference between a router and switch.
It's good.
Doesn't matter. All right, there you go. A campus network usually looks like this. So we usually have a certain amount of floors. We have the access layer. We have the distribution layer, the core layer. This is how it usually looks like. In a collapse core, we have the distribution and the core layer combined into one. They do the same things, but it basically is a combination of local area networks into a small scale. Okay, so it's not a wide area network. That's why it's called a campus network. Because people couldn't say, oh, this is a local area network, because now you have all these different levels, different departments, different things, and you also have multiple routers. So they're like, we cannot call these a LAN, we cannot call these a WAN, so let's just call it a campus network. There you go, this is a branch network. So branch network is usually comprised of a branch office and a few regional offices. So usually this branch office will be the hub for all communication. And usually what happens is the companies will have the internet WAN. This is the public internet infrastructure. And they still need to communicate with themselves in a secure way. How are you going to communicate between the sites in a secure way?
VPN, side-to-side
Through the
VPN.
internet, through VPNs. And VPNs is a topic of this course, and you have to learn how to configure a VPN in the end for assessment number 2, and you have to show it working. Right? So you will have 3 routers, one will be the branch office, the other 2 will be the regional offices, and you have to establish and create a VPN connection to the branch office. So it's gonna be nice. There you go, distributed network. So networks usually span across the entire globe, mate. That's nothing new to you. And most of the WAN connections, they're actually being done through the public internet infrastructure. And that's why we need these virtual private networks to make sure the traffic is secure, right? Encrypted. All right, WAN operation. So these are all the organizations that are responsible for creating all the standards for internet connectivity and for WAN connectivity. We have TIA, Telecommunications Industry Association, the ISO, and the IEEE, Institute of Electrical and Electronics Engineers. They will all be responsible for telling people how the connections are made, the different type of connectors, the different type of cables, the different type of devices, and everything else. Remember this? You know? This will chase you for the rest of your life, Noah. Yeah? The Australian Post sucks, they never deliver the parcels. So when we talk about the wide area networks, we are more concerned about the physical and the data link layer and how we're going to be sending out and forwarding data. What do we forward here?
Frames.
Frames. Yeah. And these are all the layer 2 protocols being used. These are the 2 that I talked about earlier today, PPP and HDLC. There's also MPLS, multi-protocol label switching, which is also widely being deployed nowadays. Now, multi-protocol label switching is mostly done at the ISP networks themselves, okay? Not to the customer. Usually to the customer is something like PPP, HDLC, or PPP over Ethernet, or something like that. Here, it's exclusively inside of the ISP. So if you like to apply for jobs as a network engineer for a telecom company, you will see these there. You need to know how to configure MPLS, you need to know how it works, you need to know all the devices, yeah. And of course, we still have the other ones here. DSL, cable, wireless, all these are standards for connecting us to the wide area networks. And we also used to have these ATM, asynchronous transfer mode. I cannot tell you much about this because when I just started studying networking, it died. Okay? And it became legacy, so I don't even know how it works. There you go. We have the data terminal equipment, DTE, data communications equipment, customer premises equipment, point of presence, and demarcation point. This is how things work, mate. Now, everything will start to make sense for you of how the ISPs do what they do, all right? So this is the ISP infrastructure. This is what you're paying for, okay? This is what your $100 a month is getting you, okay? Access to sending data here to the ISP infrastructure, to the wide area networks, and of course this ISP is connected to other wide area networks, to other ISPs, to other countries, to other ISPs in other countries, to other ISPs in other countries, to other companies such as Microsoft and Google, and there you go. It's called the internet. Yeah? So this is how things work. So you have the ISP, the WAN service provider network. Usually the ISP has something called a local central office. And these local central office will basically have a connection to your premise. Here we have a cable junction box. And from here, the ISP will basically create the connections to every single one of their customers. So for example, if you live in a building, you will have a cable junction box. In there, you will have some networking equipment, most likely routers, okay? And then they will basically be having connections to every single one of the units. And then you have NBN box, and then your router, and so on. Okay? Now, these modem that you need to actually connect yourself to the ISP cable junction box, if this is running a different protocol than yours. So let's say this is a fiber link NBN, mate. Yeah? You have a fiber link to the local central office all the way to your house, and then all the way to your unit. And then you have the modem there, the NBN box, yeah? Then you plug it in your router. Your router is the data terminal equipment, the modem is the data communications equipment. There you go, all the terminology you need to know. Cool? Of course, you have all different flavors of NBN, yeah? Fiber to the home, fiber to the premises, fiber to the node, yeah? Some of them are fiber to the node, Fred, which is absolutely ridiculous, yeah? You have the fiber optic link from the ISP central office all the way to the building entrance, yeah? And then you know what the ISP does? They still utilize the old PSTN infrastructure, the old phone line infrastructure. So they actually convert that into DSL, just from the demarcation point to your unit. And then, there you go, and they still market this bullshit as NBN, which is unacceptable, mate. Yeah? They call fiber to the, whatever, fiber to the node. Yeah, fiber to the node. It's not horrible, but it's not great. So. All right, and then you have the, yeah, we talked about that already. We also have something called the point of presence, okay? So the point of presence is usually this, okay? Every once in a while, you're gonna drive somewhere in a remote location, and you're going to see a very tiny building, yeah, with a huge antenna on top. Have you seen this before? Huge, man, huge. You'll be like, what the hell is that in the middle of nowhere? Usually it's the point of presence.
That's the tower.
That's where the ISP usually keeps all the bullshit that they have, all the devices that they have, yeah? And you actually need people to go there, yeah? And fix stuff and make changes and upgrade devices. It's fairly a nice job, Fred. Yeah? You see all these guys driving the Ford Rangers, Telstra Ford Rangers, yeah? That they would go to these places, to the point of presences, and just basically fix stuff and upgrade devices and things like that. That's a job, you know?
Yeah, I met a guy that did that. He lived in Darwin and he just drove his Tesla out to everywhere.
Sounds like a good job.
Is it field technician or something? Is it
Network engineer.
network engineer?
He
Yeah.
got to go to some.
Because you actually have to be specialized in networking equipment if you're working for the ISP. Yeah. There you go. You also have something called the backhaul network or the backbone network. The backbone network is a term that refers to all these stuff that the ISP runs. It's called the backbone network, okay, that the ISP has. So usually the backbone network is found at the point of presence. When I was doing my internship back in 2014 for a telco company, I had to go into the point of presence places and basically check it out if all the UPSs were still alive and if there were any battery fail. Ridiculous job, man. But you know, who cares? I saw some pretty cool networking equipment. And there you go, you have your serial communication. This is how serial communication works compared to parallel communication. Serial communication, you actually have to send all the bits one by one, okay, that you have. Serial communication slightly better. But the thing is, serial communication has improved so much, mate, in terms of how you actually transmit the bits and bytes. And parallel communication is complex in terms of which bit are you going to send on which wire? Which bit are you going to receive first? So it actually adds this layer of complexity. Sounds like a perfect idea, you know, for higher bandwidth, higher throughput, but it's not very common anymore because this has become much better. Yeah. All right, there you go. Circuit switch communication and packet switch communication.
Just Robert.
Yeah.
So the Ethernet cables that we're using, they're using parallel transmission?
Yeah, parallel.
Mate, believe it or not, it is not.
No.
Because each wire is doing something.
Absolutely,
One wire is sending data, the other wire is receiving data. So when we say parallel communication, we're actually saying that all the wires would be used for transmitting.
Yeah.
So it's not.
Yeah.
Yeah. So I wouldn't define an Ethernet cable
No,
as
no, yeah.
parallel. All right, there you go. Now we need to contrast circuit switched and packet switched networks. Now, circuit switched networks, mate, they're not even common anymore. Considered to be legacy nowadays. You remember when you watched the old movies from the 80s, 60s maybe? Yeah? There was a lady and someone would call someone else. And there was a lady that works for the ISP. And she had to basically manually switch the circuit, yeah, and establish the circuit so that the communication would happen. This is what we call the circuit switch communication. You actually have to switch the circuits to have a path from the source to the destination, and the path is reserved for a certain amount of time. It's reserved. So for example, you're sending data from A to B and you reserve this path. No one else could use that same path. That same amount of time.
So you're saying that the
At the
lady,
same amount of
the
time.
lady is actually the routing table?
It could be, it could be. Now the new lady is the rounding table. Yeah, it's all automated. Yeah, but that's what basically packet switching means. Because now you don't rely on setting up the circuit manually somehow, yeah, or reserving the circuit. You don't have to reserve the circuit whatsoever. All the circuits are there, all the connections are there. You're only gonna use the connection for the packet itself. You're gonna switch the packet. There is one disadvantage of doing this, mate. You have no guaranteed delivery, and you have no guarantee that the packets will arrive at the same time. You have no guarantee that certain packets will have the same latency because they can take different paths to reach the destination. Yeah? Because you're not reserving the circuit anymore. Yeah? This is what's done in Ethernet WANs, Metro Ethernets, multi-protocol label switching MPLS, frame relay, asynchronous decimal. All of those technologies use the packet switch communication. It's very unlikely we're going to move backwards and have circuit switched again. So everything nowadays is just packet switched. All right, these are all the fiber optic protocols. Okay, one of them is synchronous digital hierarchy, SDH, which was a global standard for transporting data over fiber optic cables. We also have SONET as well, which is another one, but it's a North American protocol. Right? So you just basically need to know the wording because this is what the wide area networks links are configured with. This is the protocol of choice for the wide area networks running fiber optics. And this is dense wavelength division multiplexing. It's a way you can actually multiplex multiple companies that have the same fiber optic link. At some point, you have to multiplex them into a single fiber optic connection. Okay? DWDMs will actually do that. DWDMs are actually devices. So at some point, if you've been hired to be a network engineer for an ISP, you will be familiar with the DWDMs. So they basically have all the fiber connections coming to them, yeah, all the fiber nodes, and then it basically multiplex all of them into a multi-mode fiber, something like that, yeah. Traditional WAN connectivity. Now with traditional WAN connectivity, we have dedicated or switched. Dedicated is not used anymore. No one is using leased line anymore. No one is using circuit switched anymore. So it's just basically over. All right. T1 is the serial, incredible 1.544 megabits per second, which is ridiculous for today's standards. So all of these makes pretty much dead. Okay. Nowadays we most likely have switched networks such as frame relay, PSTN, and so on. All right. Talked about that already. Yep, that's the T1 link, 1.54.4. It used to be a better standard, which was the T3 link, which was actually slightly higher, better bandwidth, 43.7, which for today's standards is not that high anymore.
It's not too bad as well.
Yeah, it's not too bad, man. Considering that nowadays we have 1 gigabit per second. This
Yeah,
is.
it depends for if it's for
Yeah.
home use or it's for enterprise. For enterprise would be
But remember,
a big problem. But
when we talk about WANs, usually expecting maybe enterprise networks. Yeah,
That's
that's what I
gonna be a
usually
problem.
think about. Yeah,
that's gonna be an issue, yeah.
and then this is
Yeah.
very low.
Yeah.
All right. Advantages and disadvantages of lease line. You have simplicity, quality, availability. Disadvantages: cost, limited flexibility. So that's one of the disadvantages of lease line. Lease line is basically you pay the ISP to use their infrastructure. That's it. All right. There are two traditional circuit switch options. We have the public service telephone network, PSTN, and the integrated service digital network, or ISDN. ISDN provided data rates from 45 kilobytes per second all the way to 2 megabits per second. So for today's standards, mate, forget about it. Frame relay, slightly better, but not that widely deployed anymore. Okay,
I hope that they won't ask about it in the CCNA because
it's not part of the CCN anymore.
that's good.
Yeah,
Because you won't
it's not
remember
part-
anything
yeah.
of this.
I had to learn frame relay, mate, and it was awful. Okay, you actually had to set up site-to-site settings. So this side talks to this side, this side talks to this side. You had to do this manually. Establish the awful. Modern WAN connectivity. So having said everything we had to talk about, the legacy ones, this is what we see nowadays in the industry. Optical networks, yeah? You have the optical fiber connection, you have NBN, you have all those sort of things. Telephone line, slowly dying, yeah? Some places still insist a lot in keeping it for some reason. And coaxial cabling. We don't have coaxial in Canberra for some reason, I don't know. But if you go to Sydney, some places still have the cable network, yeah? In the US, it's widely deployed everywhere, man. Absolutely everywhere. Yeah. And then you got cellular, wireless, and satellite. All ways you can access the wonderland called the internet. Yeah, we talked about these already, I think. Yeah. So all these technologies here, they are part of these broadband network. Yeah. These broadband WAN networks, they are DSL, cable, optical fiber, Wi-Fi, cellular, satellite, internet, WiMAX, okay, and so on. WiMAX was going to be a thing, mate. WiMAX was about to be a thing before it was killed by 4G. Okay, I was actually working in the industry at the time that 4G was created, and people were like, WiMAX is gonna be the future, mate.
What's that WiMAX? What's all about? What is that? It's
WiMAX is actually an improvement to the standard Wi-Fi for wide range.
so it's antenna channel.
Yeah, so you could have like an ISP tower
Okay.
transmitting Wi-Fi signals that could range an entire city. And that would be super fast. And then people are like, this is gonna be the future, mate. This is so good, you know? Imagine paying an ISP plan, you have amazing Wi-Fi speed connections. But then you got 4G. And 4G is quite enough. And then 5G. And then people just basically, you know, kept putting away WiMAX, you know. Just put it under the carpet, you know. And that's it. Slowly died. Alright, and then, yeah, all the technologies we have nowadays, Metropolitan Ethernet as well. Some countries, they actually have the Metropolitan Ethernet. So you actually have an Ethernet link to the ISP. But as you may be thinking, mate,
Isn't that what Australia's got?
it is expensive. Metro Ethernet?
Yeah,
Where?
I mean, the NBN's, like what the Americans would call Metro Ethernet. Oh, maybe, sorry.
No, they're slightly different. They're slightly different. Slightly
Different,
different.
are they?
Yeah.
Oh, okay. So,
They're not the same. Not the same at all.
Oh, right, okay.
Yeah.
NBN is just a proposed version.
And we also got Ethernet over MPLS, virtual private LAN services, VPLS, and a bunch of others as well. So this is what the Metropolitan Ethernet looks like. You actually have an Ethernet link to the central office, to the ISP office, and then you have all these multi-layer switch devices that will actually be switching the frames. So it's more likely, yeah, it more resembles a standard local area network in terms of switching the packets than to NBN. Because NBN is actually dealing with the fiber optic signals and not Ethernet signals to do the switching. If that makes sense.
Fibre optics over Ethernet.
No. So that's why I'm telling you the different, yeah. There you go. This is how an MPLS cloud looks like. So if you learn routing and switching, we talk about MPLS a little bit there. So nowadays we usually have two types of MPLS networks. Layer 2 MPLS networks and layer 3 MPLS networks. In the layer 2 MPLS networks, everything is switched based on labels. So IP addresses here are pretty much insignificant. The routers at the ISP, they can actually switch the packets within the ISP network using labels. Okay? It's basically a way you can save IP addresses, public IP addresses. Internet-based connectivity. Now, we have the wireless options that we already discussed. For wireless, we have 3G, 4G, 5G, and beyond. Satellite internet services as well if you live somewhere far away from civilization. Yeah. There you go. This is DSL technology. You're basically finding a way to have both the phone signals and the internet signals sharing the same medium. Okay. There you go. You need the modem to basically do the modulation, demodulation, which is basically translating from one data signal type into another. Okay. You remember back in the days you had the DSL modem and you had the modem and you still needed a filter to actually filter your phone signal from your internet signals upstream, downstream, yeah. It was ridiculous filter that you plugged in, yeah, at the phone port, and it filtered. That was just basically a low pass filter. It was just passing these low frequencies and blocking everything else. There you go. The ISP is usually PPP. That's what I just discussed with you guys. Most likely PPPoE. If you're running something like NBN or even DSL uses PPPoE as well. Yeah, there you go. Cable technology is similar as well. You still need a modem because you need to convert the signals from a coaxial cable into Ethernet signals. So you still need an optical modem and so on. Alright, and all the flavors we already discussed. The fiber to the home, fiber to the building, fiber to the node. Yeah, talked about that already. And all the different Wi-Fi solutions as well. Municipal Wi-Fi, cellular, satellite, internet, WiMAX, so on.
Are we learning all this just for information, or are we going to be testing it?
No, just for information. Yeah.
Right.
This is not part of the assessment next week. But you guys need to know this.
No,
If you want to survive. If you want to survive. Yeah?
It's in the CCNA, right?
Yes. And if you want to do the CCNA, it will be there.
So
Back
the
will be
final exam will have this stuff in it.
Yes. Final exam will have this stuff in it.
Just a lot.
So check it out. I think this is the last thing we need to talk about, which is just basically ways you can connect the edge router to the ISP. One way, mate. Single homed. Every time you see these terms single homed, it just, the term homed means you just have one ISP. So this is single homed. This is still single homed. Okay? But it's called dual single homed because you have two ways of getting to the ISP, two connections. This is called single multi-homed. Multi-home because you have multiple ISPs. And it's single because it's just one connection to each ISP. And this is called
Dual single multi.
dual multi-homed. Yeah.
So,
So that's the terminology.
in all those that.
It is confusing, man. It is so confusing. But just remember, homed is in terms of the ISP. Okay?
Okay.
So single homed, just one ISP.
It's all one single point of failure in all of those topologies, so it's
Yeah, you still have one point of failure, which is your edge router.
yeah.
Yeah. So here you're just having ISP redundancy.
If one ISP fails, you have another ISP.
You have
which
another,
is-
yeah.
Usually doesn't.
Money. Yeah? Talked about that already. There is a lab for you guys to do. Research some technologies that we discussed here today. And that's it, mate. No one is gonna celebrate? What time is it? Ah, man, it's still 7:40. Yeah? Just keep going. I'll go back.
Let's start from the beginning.
Stuff in the beginning.
Yeah.
So there is a lab for you guys to do different WAN connectivity options, packet tracer. And next week is the assessment, okay? Most likely on Monday, I will make the final decision if I really make you guys configure all devices, okay, physical equipment, or if I'm just gonna require you to configure one of them, show it to me that you're capable of configuring one of them, and everything else you do on packet tracer.
What's the difference if we just configure one physical device?
Yeah, there's no
It'll be
difference.
the same as
Yeah.
with the packet tracer,
Yeah.
right? I mean, it's the same.
So do you guys want to agree? Let's do this. Yeah? Who wants to do this?
Do this what? What is this?
The second option. You're just gonna configure one router. So you show it to me that you're capable of configuring one physical router, but you still need to complete the packet tracer activity.
I think we've compromised, Robert.
We need to do it in shifts otherwise.
Agree with that one? Cool. So we agreed. That's what we're gonna do. Okay? So I'll bring a router for each one of you guys, and then you guys configure just one router, show it to me, and that's it.
If we can't come to the practice labs, right, for the physical equipment, is there something that we need to know before the assessment? Because when we come to the assessment, we need to.
Make sure you don't.
Yeah, so the only thing you need to know is, guys, pay attention here. If you don't know, if you've never configured a router before in your life, I've actually created a guide here for you guys. Well, just wait a minute. Just gonna log in again. I'll show you that. So I'm doing the teacher's training, man. You know, one of the assessments I had for the teacher's training was to basically create a resource for you guys. And I decided to create a step-by-step guide on how to configure a Cisco device. Okay?
You have assessments for your training? Oh my god. That's
It's the same
intense.
board, I don't.
And check it out what I did for you guys, mates. Come on. Where is that again? Did I put it here? I think I put it, here, session 7. There you go. Okay, configuring routers and switches. If you click here, it will show you exactly what you need to do if you never configured a physical device in your life. Step number 1, you gotta make sure you have a virtual terminal emulator software. For example, PuTTY or TerraTerm. Okay? All about the life decisions. Okay? Choose any of them. Okay? I recommend PuTTY because it's easier to use. At least I'm more comfortable with PuTTY because I've been using PuTTY for the past 10 years.
It's like 2 clicks.
Alright? So it's 2 clicks. Once you know you got PuTTY installed, you need these guys here. A serial cable or console cable. It's an RJ45 to serial or RJ45 to USB. You already have a cable like that in your workstation. You will already have PuTTY installed in the image that I will give it to you. Okay? So it's just a matter of you making sure the cable is connected here
Can I use my laptop and connect the cable?
as well if you want. Yeah. And making sure in the patch panel you connect another cable there, and then if it corresponds to the same number as you have in your workstation for your serial cable, you will then have a serial cable. And then you plug it into a console port of the device, enter PuTTY, just like I'm showing you guys here. Serial, and there you go. Right? You in. And by the way, there is something. Oh, I forgot to do that.
Someone sent you a message already.
Just give me a minute.
These switches are good because they've
Activity.
console. They've got the console ports on the front of these switches. Upstairs they've got the console ports on the back. So you've got a bloody, you know, I've got wiring these ends, got 5 heads sticking behind the rack trying to find their own bloody console ports, you know.
The fun part about doing these assessments is making sure the cables actually work.
Oh yeah.
Preferably ahead of time.
I brought in last year I brought in, well last semester I brought in a rack. I brought in my own cables, mate. I did.
Mainly because I think
Yeah,
you're
I
wasting
used
time
that
trying to
with
figure out if they work or not.
You got a wiring.
So check it out.
I was like, that's not very.
I also had to do this as part of my teacher's training course. So I created an activity for you guys to review if you know how to do this stuff. So it's a drag and drop. So let's do it.
Assessment 1 done.
So what is this?
First one, virtual.
Install a virtual terminal emulator? Hey. You can see we learned stuff in the teacher's training course. And this.
That's 2, right?
Is this where you guys go on Monday?
Plug in and connect the cable, the console cable. And then, what's this?
It's already in order, is it? That's 3. It's the same order.
That's 3. How about this? No, it's not the same order, mate. Come on. Are you underestimating me?
Oh, okay. The last one is the 4th.
There you see it. I've included some randomness here. There you go. And then, let's check it out, mate. You guys sure?
Yeah.
Yeah, there you go. See?
Well done.
Teacher's training course, mate. You believe it or not, every Monday I have to go to CIT Bruce from 9 to 3 p.m. just to learn how to do this stuff.
Still, I thought you already had that.
I have the Surf 4,
Oh.
but the problem is
How long is that this one, the current one?
this one is the diploma in vocational training.
Oh,
It takes a year, mate.
you need that as well. Oh my god.
Yeah.
Thanks, Scott.
Yeah, I'm telling you, Fred, it's not easy to be a teacher, mate. Do you want to be a teacher, Fred, by the way? Do you want to be a teacher? We need teachers, mate. You're getting so many good job offers, so
Yeah, forget about it. Never mind.
Don't worry about the 250 grand. Do the
I'll see you
guys.
Robert, so this cable is not USB serial cable, it's
serial. So you don't have the same port on your laptop.
no, I don't have this one. I need.
Yeah. So just use the computer.